In this video, we're going to explore equivalent fractions, and we're going to do that by using paper folding. So we're going to need some rectangles of paper, and we will also need a multiplication square. We're going to start off by taking a rectangle of paper and folding it in half. And I've already coloured in half one of those two parts, so we can see half. So here we can see my rectangle folded in half. And so when I want to record that as a fraction, I can see altogether I have got two parts, equal parts, and that's my denominator. And I have coloured one of those parts. So we can see that's 1/2. Now, to make an equivalent fraction, I'm going to take that piece of paper and fold it the opposite way. So folding it horizontally. And I'm just quickly going to draw the line in to make it easier to see. So we can still see that I've got the same amount coloured. I've still got 1/2 coloured. But now we can also see that there's a different way to record that fraction. Instead of having two parts altogether, I can see that I've got 4 parts. And instead of having 1 part coloured, I can see that I've got 2 parts coloured. When I look at my fraction now, I've got 2/4. I can see that I've doubled how many parts I've got altogether. And I've also doubled how many parts I've got coloured. So I've got twice as many parts altogether and twice as many parts coloured. So 2/4 is exactly the same as 1/2. It's an equivalent fraction because the amount that's coloured, the amount we're looking at here, is still exactly the same, but the numbers in our fraction are different. So now I'm going to take that fraction, fold it in half and in half again, and then I'm going to fold that in half again. So now when I open up my paper, you can see I've got even more parts. So I'm going to just quickly draw them in. And I can see now I've still got exactly the same amount coloured, but this time I've got 8 parts altogether. So in total, there are 8 equal parts. And now I've got 4 parts coloured. So now my fraction is 4/8. It's still exactly the same as 1/2. The amount hasn't changed, but I've recorded it in a different way. And I can see that this time I have got twice as many pieces as I had last time altogether. And I've got twice as many pieces as last time coloured. If I go back to my starting point and get a different colour, I can see from where I started with 1/2 to get to 4/8, I've got 4 times as many pieces coloured. And to get from 1/2 to 4/8, I've got 4 times as many pieces altogether. Started with 2 pieces altogether, and now I've got 8. I started with 1 piece coloured, and now I've got 4 pieces coloured. So if we multiply our numerator and our denominator by the same amount, we will make an equivalent fraction. So now let's look at a different fraction. This time I folded my rectangle into 3 pieces and 3 equal parts. So again, I can record this as a fraction by saying that I have 2 parts coloured yellow out of 3 parts altogether, 2/3. And I can follow the same process as I'm going to fold it in half. So now I can see altogether I have got 6 parts and I've got 4 parts coloured. So again, I've got twice as many parts altogether and twice as many parts coloured. I'm going to swap this for my original fraction, my 2/3, and this time I'm going to attempt to fold it into 3, fold it twice into 3 equal pieces. And when we work on fractions, I do tell children that we want to be as accurate as possible. We try to make equal parts, but when we're paper folding or representing fractions with drawings, it is difficult to make them exactly equal. So we do our best and we know that they should be. So now when I look at this one, this fraction, I can see I have got 9 pieces altogether, and I have 6 pieces coloured. So starting from my original 2/3, I can see I have got 3 multiplied by 3 is 9, 3 times as many pieces altogether, and 2 multiplied by 3 is 6. So 3 times as many pieces coloured. I could continue this pattern. My next fraction would be, well, I can see here, this looks familiar. I have 3, 6, 9. I'm counting in threes. This is my 3 times table. My next fraction is going to be 4 times as many pieces. 3 multiplied by 4 is 12. And that means there will be 4 times as many pieces coloured. 2 multiplied by 4 is 8. So now that we've seen the connection between our multiplication facts, or times table facts, and equivalent fractions, we can use the times table square to actually spot equivalent fractions. If I go back to my original fraction, 1/2, you can see that here, if we look at 1/2 and look at those 2 rows, we see all the fractions we found. So we started with 1/2 and we spotted that 2/4 was an equivalent fraction, as was 3/6, 4/8, 5/10. Each time we go along those 2 rows of multiples, our 1s and our 2s, we're finding an equivalent fraction. And we could keep going infinitely. I could choose a different fraction. So let's think about 5/7. So starting off with 5/7, I'm just going to put a chopstick across there so that we can more easily see our fraction. So I've got 5/7. If I needed to know how many 28s that would be the same as, I can go across my 7ths and find 28, and then go across my 5s and find 20. So 20 28s would be exactly the same amount as 5/7. It's an equivalent fraction. because I've multiplied my numerator by 4. I've got 4 times as many pieces coloured, and I've multiplied my denominator by 4. I've got 4 times as many pieces altogether. So I know it's the same amount, just written in a different way. I hope you've seen how paper folding can really help to make the link between multiplication facts and equivalent fractions, and being able to use those times table facts that we know to make an equivalent fraction will be really useful when we want to compare or calculate with fractions with different denominators.